Hey, this is Scott. Welcome back. So, we're going to continue with our series. This brief video is part of that series and what I'm doing for Bayesian statistics and decision making. So, I hope you join me for Bayes01, where I introduce my intent for the series. So, please see that brief 3-minute video out there. So, this is going to be brief, but I wanted to cover a couple of topics. One is just an introduction of the three forms of statistical procedures. So if you look at it, and this applies both to Bayes and non-Bayes, so you have really three different areas, right? So descriptive statistics is the simplest. Descriptive statistics are what you read in the newspaper often, sports statistics, anything that describes a population or attempts to describe a population from a sample. So everything about statistics is you start with something that you want to know more about. That's the population. You take a subset of that, and then you make an inference in the second category. So you can first describe, calculate means, averages, baseball stats, RBIs, etc. And then the second category is inferential statistics, where you're actually making judgments. So on the sports analogy, maybe I'm trying to estimate what a player might do in the coming games or for the season, what his stats might be based upon his past experience. And so I use those descriptive statistics and some statistical tools, and then I come up with inferential statistics about what this person might do next year. And then finally is the statistical decision theory, and that essentially goes one step further. And instead of making just statements or making judgments, the decision maker uses the information to choose among competing alternative actions. So the common denominator in all three of these is uncertainty. Uncertainty exists in across statistics. That's really the whole idea. In fact, you'll hear me say that statistics is not about getting the statistics in a nutshell is about quantifying uncertainty. It is not about eliminating uncertainty. It's about understanding and quantifying how much uncertainty is really there. Okay, I can go off sometimes. So let me go to this. I want to keep this very brief. So if you look at the Bayesian approach, so again, all three of those categories could be classical statistics, but this series is on Bayesian statistics. So let's talk for a minute about the difference between the two. So classical or frequentist statistics is the primary courses that are offered in high schools and universities. So that essentially is repetitive in nature, where you are determining, again, from a sample, making judgments about populations, and you use basically a repeated sampling paradigm. Like if you were to take 1,000 different samples, the math is kind of built on that aspect of it. Versus Bayesian statistics, which is really built upon Reverend Bayes. He developed this reverse probability formula, and they've called it Bayes' theorem. And so we'll be talking quite a bit about that and how we use Bayes' theorem. But one of the key differences between the two types of statistics, the classical versus the Bayesian, is using prior probabilities. So Bayesian uses the prior knowledge from someone, whether it be a physicist, whether it be a stockbroker, or a teacher or whatever. Basically, we have all this previous information from our experiences, and the classical group really kind of just ignores all of that. But the Bayesian assigns a probability distribution to our knowledge called a prior probability They use that plus the data that's available, and then combine the two and come up with a true probability distribution of what might happen. So easy example off the cuff would be, say, a physicist, experimental physicist that's been doing physics for 20 years, and they have a lot of past knowledge about a phenomena. They model that past knowledge in a subjective prior probability, and then they run an experiment and actually collect new data and combine their prior subjective probability with the objective experimental data, combine those together and come up with this posterior. And so we'll be talking, obviously, more in depth about that. And the crux of it, mathematicians really argue a lot. So if you look at the classical or the frequentists, they'll say things like, you got this prior, and that's all subjective. Well, it turns out, and we'll talk about it next time, all probability is subjective. There is no such thing as objective probability, because it is a model, and those models are in our heads. Even if you flip a coin 1,000 times, that's the frequentist type thing, and you get 490 heads, then and 510 tails, you can make judgments on that. But essentially that is subjective, because that uncertainty rests in your mind, not in the penny or the coin that you're flipping. It's in your mind, is where it's right here where that uncertainty exists. And so we'll talk more about that. But then lastly, for this is why there is a big rise in Bayesian methods. They're becoming really in vogue. You're seeing more and more and more uses of Bayesian methods. Why is that? Well, the main reason is computing power, because classical statistics is really good with closed form solutions. That means things like averages, right? You sum up all the numbers, divide by the number of numbers, and you get an average or a mean. And so classical statistics is ripe with things that have formulas, right? So you use calculus, you develop formulas, and then you just apply formulas. In Bayesian, the math is less tractable. So you, in a nutshell, you have to often simulate the examples. In other words, you're using a computer to approximate, and it turns out you can converge upon a solution. So yeah, that's the difference there. And since we now have really powerful computers, there's no argument that you can't, use that. All right, so that's the introduction that I wanted to go through. Next time we'll starting to peel the onion, and we'll be talking about modeling uncertainty with probability. That's actually going to be probably, 6 different videos. We'll start out. I like to make these, less than 10 minutes. 8 to 12, something like that. So we'll break that into pieces and present that, and then we'll get into these other topics that I talked about in the intro. So if you're just accidentally following upon this video and you want to actually see the entire playlist, in fact, this playlist is going to include a lot more than this series. We'll talk about R and Python and causality, and that is but the whole playlist. But if you'll type in my name, Scott Burke, and you'll open that playlist, you will see this series, and it's all going to be labeled Bayes00, 01, 02, 03, and 04, etc. So thanks for stopping by. I'd love a thumbs up or a comment. So we'll see you next time.